Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
All right, it is my pleasure to introduce Leon Gatys. Leon is a PhD student in Matthias Battke's lab in Tübingen. And his PhD is about using CNNs and linking them to biology. And today he's going to talk about how to use CNNs to transfer style. And thank you.
Yeah, thank you very much for the kind introduction. So I'm Leon. I'm very happy to be here today and talk to you about a neural algorithm of artistic style, which is joint work together with Alexander Ecker and my supervisor Matthias Bethke at the University of Tübingen. So in our work, we use a pre-trained convolutional neural network for image processing. So there's actually no learning involved. And in particular, we use the convolutional part of the 19-layer VGG network. So we all know that when we show an image to a ConvNet, the information about that image is represented in the different layers of the network in terms of the feature maps. And actually, each feature map is just a filtered version of the input image. So for the purpose of this talk, you can think of a CNN just as of a multi-scale nonlinear filter bank. Now, and we can visualize the information that is preserved in the feature maps in a particular layer of the network by finding a new input image that produces the same feature response in that layer. And if we do that in the lower layers of the network, we sort of get back to the original image. Whereas when we go up to the higher layer, we find that much of the information about the detailed pixel values is lost, but the information about the content of the scenery and the objects in the scene is still preserved. And there's actually a CVPR paper from this year about that by Andrea Veraldi's group that goes more into detail. Now, we have a paper at this conference where we show that if we not constrain the actual feature activations, but the correlations between feature maps in a number of layers, we get a pretty good model of natural textures. So if capital F is a matrix of feature maps in a particular layer, so each column is a vectorized feature map, then we just take a matrix of the matrix of inner products, so a correlation matrix, where each entry is just a dot product between two vectorized feature maps to transform the feature map to transform the feature map representation into a textual representation that has lost all the information about the spatial content of the image. And if we do that in a number of layers of the network, and we then find a new image that matches this texture representations, we can basically get a texturized version of any input image. Now, to perform artistic style transfer, what we will do is we will extract the texture information from painting, and the information represented in a higher layer of the convolutional neural network of the photograph, which basically preserves the content of the image, and we will combine both of these representations into a new image that actually combines the style of the painting with the content of the photograph. So how is that done in practice? Well, we first show the painting to the convolutional neural network, compute the feature map activations in response to the painting, and get the correlation matrix on a number of layers of the network. Then we show the photograph to the neural network, and we compute the feature activations in response to the photograph. And then we show a white noise image to the network and basically compute the correlation matrices in response to the white noise and compare those with the correlation matrices in response to the painting. And we do that on a number of layers of the network and get a loss function that is just a linear combination of the loss functions in the individual layers that basically measures how far away is the style or the texture of our image that we generate from the texture of the painting. And then we basically, and then at the same time, we compare the actual feature map activation in response to the white noise with those in response to the photograph. And then we get a total loss function that is just a linear combination of this loss function that measures how far we away from the style of the painting, and the loss that measures how far we away from the content of the photograph. And we can then just use the usual optimization procedure of convolutional neural networks and compute the gradient of this loss function with response to the feature map activations in the convnet, and use a standard backpropagation procedure to obtain a gradient with respect to the pixel values. Now we can use this gradient just as the input. So this just gives us a function value and a gradient with respect to the pixels. And we can use that as input to any optimizer and perform gradient descent on the input image. And we can do that until we converge to a very small loss and basically obtain an image that simultaneously minimizes the distance from the style of the painting and the content of the photograph. And I prepared a movie to have a look how this image generation works in practice. So we start from the white noise, and we will now see the gradient descent on the input image to then generate the new image. And so we can see that basically the network starts with matching sort of the low-level features and the color map of the painting, and then gradually gets the content right of the photograph. And now we see the gradient descent is almost converged, and we can sort of skip through a few steps, and you see the painting basically doesn't really change very much anymore. But yeah, sorry, I will. Basically, we end up with a with a new image that combines the style of a Van Gogh painting in this case and the content of the Nips poster. Now I just want to make the point that this is not only constrained to artistic style transfer, but we can actually also apply this technique for general style transfer. So here I have a picture of New York by night and London by day. And so we can use the style transfer technique to turn the image of London by day into an image basically by London by night. And with that, I think I want to leave you with a few impressions of my university town, Tübingen, basically in the style of several painters. And I guess some of you already seen these images, but I think it's nice to show them anyway. So this is a photograph of Tübingen. So this is Starry Night. This is Picasso. So many, or not many people actually know that all those great artists have come to Tübingen and paint this. So this is Munch, The Scream. So this is a bit older. This is Turner. So Turner went to Tübingen on a very stormy day, apparently. And to have something more abstract, this is Kandinsky. Yeah. And with that, I want to end, and I want to thank you very much for your attention. And if you're interested in trying this out yourself, you should check out deepart.io. You can upload pictures there. And if you want to see more examples of textures, you can check our website. Yeah.
Thank you. Thank you, Joshua.
So why not initialize from one of the two images?
Oh, you can do that as well. It doesn't change very much. I like the initialization from white noise because there you can basically sample many different versions of the same image, right? If you initialize with a deterministic seed, then you always get the same image. But it's true that if you initialize from the photograph, I feel that usually the pictures look maybe a little bit nicer. But the pictures I showed you here, I think they were initialized from white noise. Yeah.
Yes.
Hey, have you explored an analogy for text such that it's possible to, let's say, take an author, take a style, and put some other content on there?
So we haven't done that. I have seen something online where some people tried. It didn't look very impressive so far, but I guess like if you have the right network architecture, it could work. I personally have never worked with audio data, so I'm not really sure. Yeah.
Any other questions? Yes?
Have you tried building a generative model of the covariance matrices of the features in order to try to generate new styles?
So I looked into that, or I'm looking into that. It's not completely straightforward because you're not really. So you can't be sure that that there actually exists images for any covariance matrix you can sample, right? So it might be that actually in this textual representation space, it's only a point cloud of the examples that you get when you input images, right? And there's no smooth manifold that you could model with a density model. So, but it's a very good question, and we're looking into that. Yeah.
Last question.
Hi. How do you explain that taking the covariance matrix captures the style?
So I think you should. So you have to think about as texture modeling. So it's really like a texture transfer algorithm, and so the fact that spatial summary statistics on feature responses captures texture very well. That's sort of it's not super surprising. That it works so well with deep networks that are trained on object recognition is very interesting, but it's just a spatial summary statistic. So you can also, the simplest case would be just taking the mean feature map, and that already works sort of well, and that's just the second order thing, and that works really well, yeah.
I mean, it reminds me all the work by Simoncelli, Higa.
Absolutely, yeah.
Using wavelet transforms, and this is a nonlinear version of that.
Exactly, yeah.
Very last question.
Yep. I really like your work, and actually launched your algorithm on WeChat, but due to lack of money, we didn't continue with that. But we attract a lot of users. A lot of them are boys using the algorithm to depict for their girlfriends. So one of the problem we found is that for faces, it's kind of distortion a lot. But a minor suggestion is that if you don't pick a specific layer for content, but you only pick the lower level first for a couple of iterations, and then change to a higher level, it actually will make the faces and the textures even more clear and with a better shape. Yep. So have you done some experiment as well? I saw you just use a single layer of the content activation.
So I've tried using different layers for the content, and I found it crucial to take higher layers for that. I think with faces in particular, it would be super interesting to use networks that are actually trained on face recognition, because this network here is trained on objects, right? And I think in ImageNet, there are not that many faces on a large scale. So, but thank you very much.
Yep, thank you.
Let's thank Leon again. Thank you.
Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.